Thank you for joining us for another edition of Not Your Father's Data Center. I'm your host, Raymond Hawkins, Chief Revenue Officer at Compass Data Centers. I am joined by Uptime Institute's Chief Technology Officer, Chris Brown. Chris, thank you for joining us.
Glad to be here.
And if I remember right, Chris, aren't you joining us from somewhere outside of Tulsa? Is that the best, as close as we want to get?
Yeah, I am just outside Tulsa, Oklahoma.
Chris, thank you so much for jumping on with us. We would love to hear a little bit about you. I know Oklahoma is home, but you did a stint down here when you went to school. Talk a little bit about your time in and out of Texas and in Oklahoma, and how what path led you to end up being at Uptime Institute.
Certainly. Well, I'm actually from Texas, north central Texas, just north of Dallas, and I went to school at the University of Texas in Arlington and pursued a degree in electrical engineering. And it was kind of interesting how I got into the data center industry. I just fell backwards into it. I graduated from college in 1995. Data centers were, they were going strong, but they weren't widely known. The industry didn't publicize itself very well. And while I was in college and in my senior year trying to look for a job, American Airlines was on campus, and they approached me and wanted to talk about, their Sabre division. And so after a little bit of that, we kept the conversations going, and that's how I found myself in Oklahoma. So a Texas boy that swore up and down he probably never lived in Oklahoma has spent over the last 25 years here.
On the wrong side of the Red River.
On the wrong side. But
all right.
It was a good thing because I got into data centers through Sabre. And it's been, that life has been very good to me. I've been fortunate enough to be able to get into some different companies when they were in times when they were doing a lot of work and a lot of changes. So it allowed me to, get 30 years worth of experience in about 10 or 15 years. And so it's been very good. And I've enjoyed working in the industry and look forward to many more years to come.
All right, so if I remember right, didn't Sabre have a big presence up there outside of Tulsa, right? Wasn't there a big data center facility in the Tulsa area? Am I remembering correctly?
Yeah, Sabre had 2 data centers right on the airport property.
Okay.
So if you think about it, in Tulsa International Airport, American Airlines had a long-term lease on a lot of property just on the edge of the airport.
Okay.
And so when American Airlines built their data center, they built their first data center out of an old office building.
Okay.
And then they actually built a purpose-built underground data center there on the airport property that could continue to operate even if they had a unfortunate crash there. And so they had two decent-sized data centers there. Then when they spun off Sabre, Sabre built a third data center a little bit further off the airport, about 10 miles away, but still in that area. And it's a fairly large data center, and it's still in use today. It's about 5 acres under roof.
Oh, my goodness. 5 acres. That's a chunk. All right. Okay, so Sabre, which at one point wasn't Sabre part of American, and then it became its own outsourcing, for lack of a better term, business. Do I understand that correctly, Chris?
Yeah, Sabre was, created by American Airlines to handle their own reservations systems, which then expanded into their operations systems. Basically every aspect of the airline was managed through the Sabre systems. They had tried for years and successfully in some areas to expand and provide those services to other companies and other airlines and rental car companies, hotels, and things of that nature, but they were seen as competitors. And so about 1997, they decided to spin it off into its own individual company. So Sabre kept operating the data centers and providing the IT services, and tried to expand into different companies in different areas.
So walk me through the transition from doing American and Sabre and travel and the data centers there in Tulsa. Where do you jump rails and head over into the Uptime Institute and start teaching the industry how to think about this stuff?
Well, it was once again, most opportunities are those that just are surprises rather than things that are planned. I worked with Sabre for a little while. Sabre was getting ready to spin off its data centers to ultimately EDS, but at the time we didn't know who it was. And all I knew was Sabre was getting out of real property. And as an electrical engineer, real property is pretty much what I do. And so I left Sabre, did a little stint in the petroleum industry with CTO Petroleum, working with their laboratories, their pipelines, their lube oil plants. When they found out I knew something about data centers, I kind of got into a lot of their laboratory stuff. But then, EDS was operating those data centers, the old Sabre data centers, and I knew some folks that were there, and they were having some troubles, and I kept telling them that how to fix the problems. And then one day, a gentleman from Trammell Crow Company, who was their operating company, called me up, and it was essentially put up or shut up. And it was an opportunity to go work for them. So I worked for them for a few years, did a little sideline as well after that. So Trammell Crow for about 5 years, and then did some contract engineering work due to some family issues, and I need to be home more often because, as you probably know, if you're working in a data center, it's pretty much an 80-hour-a-week gig or more. And then those family issues got solved, and I was looking to get back in with the team. And a friend of mine that I'd known for years and worked with in Sabre and some other places called me up because the Uptime Institute needed some engineering help. And so I took that opportunity and started working with Uptime Institute. And so with Uptime Institute, I started that in 2010 and have worked my way up from, a consultant delivering their certifications for data centers to being the CTO of the company.
Be 12 years here next month, or 2 months, won't it? Is that about right?
It will be. I started in January 2010.
All right. 12 years. That's a long gig for anywhere. So congratulations on that. All right. So talk to us. So we've gotten you a Texas boy that ends up on the wrong side of the Red River. Got schooled on both sides, right? UT Arlington and I think Oklahoma State, right? So you get educated on both sides of the Red River. So and understand the American Airlines piece of it. So now you're at the Uptime Institute. Tell me what in the early days, because if I think about it, I know you're talking about data centers in 95 and 96. I mean, there have been computers living in buildings for a long time. But as far as the wholesale sort of commercial approach, that's an early 2000s kind of a thing. What did the world look like 5, 6, 7 years in when you joined the Uptime Institute and commercial wholesale data centers were still fairly new in 2010? What were you guys doing? What were you guys teaching the industry? Talk to me about the early days, and love to hear how it's transformed in your 12 years.
Well, back then, when the retail data center industry was just getting going and establishing its footprint, they were needing to capture business from the enterprise, and convince the enterprise companies that it was better to use them for their data center space rather than build their own and operate their own data center space. And one of the challenges that was happening at the time was having all those folks that had spent 10 years, 15 years, 20 years designing and building data centers for specific companies and operating them for specific companies to trust anyone outside of them as a place to house the IT. So, that was a big challenge then. And, we worked with some of the co-location providers at the time and talking to them about the tier standards, because there were some, that were not really adhering to really any standards at all. And they were trying to learn the ropes as well. It was a burgeoning industry. And so, we started talking to them about the tier standards and tier certification and things to prove that they were designed, but also compliant and perform to those tier standards.
So, Chris, did the concept of tiers, is that an Uptime concept? Is that where tiers started? Or was there already a notion? Okay, so putting that title, you're a tier 2, tier 3, tier 4 data center, started at Uptime.
It did. It started at Uptime Institute, and it was one of those things that, Uptime Institute had been talking about tiers since before 2006.
Okay.
And, there was a lot of discussion there. And Uptime Institute had been involved in the original, I guess you say, birthing of tiers well before that. But they were starting to, commercialize it, get the market and the industry familiar with the tier standards, tier requirements, things of that nature. And so when I came on board at the Uptime Institute, I'd had exposure with tiers before then. And when I came on at the Uptime Institute, we were trying to, we talked to and convinced a lot of players in the co-location industry that the way to communicate to enterprises that their facilities were quality, that they were designed and built to rigorous standards, was to, use tier certifications for that. And so that was what was going on at the time with co-location data centers. And, things have changed so much since I first started in data centers, since I first started at Uptime Institute. When I started at Uptime Institute, there were 4 people delivering the technical work, and they were all U.S. based. Today, we have 34 engineers scattered across 13 different countries, and still growing. So it's definitely changed a lot. But the data center industry has changed a lot. When I first started, chilled water plants were the norm, because the electrical power that was required to run a chilled water plant was about 25% of what it would be with direct expansion. And so the chilled water plants were all customized. The people that were operating them were well trained and had to be well trained and were highly experienced. When I got into the industry, most of the mechanics and the chiller operators were, they were in their late 40s and had been doing it forever. In fact, when I was responsible for operating data centers, one of the things that I did was stole people from the hospitals, because they understood mission critical, and hospitals had the same systems as data centers. But over the years, what we've seen is, as technology has improved, the direct expansion technology, as well as, using evaporative cooling and other approaches, has brought the cost of using direct expansion down to pretty close to what a chilled water plant can run. And so then that little elevated cost of direct expansion in terms of energy costs can be offset, because the rigorous skill sets of the operators are not quite as much. If you're having to worry about running chillers, you got to worry about flows, hydraulics, pressure differentials, temperature differentials. Direct expansion, most of the time, you tell it what set point you want it to be, you tell it to run, it runs. And if it doesn't run, well, then you have to have a technician anyway, because you're dealing with refrigerant gases and other things that require special licensing to deal with. So that's been a major change. What we've seen in the industry, in the last 10 or 15 years, is just the move to large scale direct expansion plants.
So before we get too far down the technological changes, especially since you were there when tiers became a thing, let's go back. It's kind of funny, a little bit like Coca-Cola or Kleenex, right? Everybody just says Kleenex, and what they mean is tissue paper. When people say tiers, that's an Uptime thing, but everybody knows, right? I see it in RFPs. I see it in any communication with brokers. They say, hey, here's the tier. Will you walk us through? I don't even know if I can even begin to say what a tier 1 data center is. Just quick bullets: tier 1, tier 2, tier 3, tier 4. What are the major differences?
The tier rating system has 4 tier levels, 1 through 4. They're progressive, which means that the subsequent tier levels have all the requirements of the previous tier levels and then add some on top of it. The first 3 tier levels are about providing increasing levels of opportunity for maintenance without impacting the critical load. So if you start with tier 1, a tier 1 data center has just enough of everything. So just enough on-site power production, which is typically engine generators, just enough cooling capacity, just enough UPS capacity for whatever load that the data center is going to operate. So you could have a single UPS, a single chiller, a single engine generator. And that's tier 1. Tier 1 provides no opportunities for maintenance without impacting the critical load. Then you step up tier 2, which is redundant capacity components. So if you think of a data center, all systems have capacity components. So a chiller is a capacity component, something that creates the capacity. The piping and the pumps are distribution paths. All right. Same thing in electrical. UPS system itself is a capacity component, but all of the cabling, the PDUs, things of that nature are distribution paths. Tier 2 requires at least one redundant capacity component for all systems. So you'd have to have at least one redundant chiller, one redundant air handler, one redundant UPS. It does still allow a single distribution path. So where Tier 2 steps up into is you have the opportunity to conduct maintenance on your on your capacity components without impacting your critical load, but the critical distribution path is still a single path, and doing any work on the critical distribution path will still impact your critical load. So then you get to Tier 3, which has all the requirements of Tier 2. So you have redundant capacity components, but Tier 2 only has a single distribution path. Tier 3 requires redundant distribution paths. So Tier 3 gets into full concurrent maintainability. So every capacity component, every distribution path, every system touching a critical system must be able to be isolated and for planned activities. And those planned activities could be maintenance, upgrade, or replacement. And it has to be able to be isolated without impacting the critical load.
We have redundant capacity as well as redundant paths, so I can do all the work without changing delivery to my critical systems, is what I think the key designation for Tier 3. So hit us with Tier 4, Chris.
Okay. And Tier 4, so Tiers 1 through 3 is about increasing opportunities for maintenance, from no opportunity for concurrent maintenance without impacting critical load, which is Tier 1, all the way through Tier 3, which is full maintenance without impacting your critical load. Tier 4 adds the idea of fault tolerance. So if you think about it, Tier 3 is about planned activities. You plan to go perform maintenance or do an upgrade on a system. Well, Tier 4 adds in the idea of an unplanned activity, which is a fault or a failure. So with Tier 4, the requirement basically is that all systems must be able to respond to a fault or failure without operator intervention and without impacting critical load. So if you think about it, if you're running a chill water plant and you lose a chiller and the chiller spins offline, the system has to detect that the chiller has been lost, start the redundant chiller up, and continue to serve the load. And it's without operator intervention. It's all automatic, autonomous response. And so Tier 4 gets into being able to deal with any single event, whether it be a planned activity or an unplanned activity.
Got it. All right. And there's the 4 that you hear thrown around pretty casually in our industry today, which is pretty incredible. You were there in the early days. I mean, Tier 4 is Tier 3, pretty casually mentioned standards that everyone largely has their arms around, or at least thinks they do. So I appreciate the refresher. All right. So the business has grown incredibly. You're in, I think you said 13 or 14 countries. Talk to me a little bit about as the industry, and I liked at the beginning, Chris, you talked about we had to convince enterprises that they could put their computers somewhere else. Without a doubt, had to convince them that it could be run safely, securely, reliably in another facility. What is it that Uptime is helping providers and customers with today? I certainly get those early days of, I'm not sure I'm ever going to let these servers out of my building. That question seems to have been answered. What challenges are you guys answering for people today?
Well, we still answer some of those same challenges. A lot of our tier certification work is about helping people to ensure that their facilities are designed to provide the availability and resiliency that they need. If you think about a lot of companies don't hire their own engineering staff. When I worked at American Airlines, I was on a team of engineers that the company actually employed. And a lot of companies just don't employ those detailed design engineers anymore. And so one of the things that we do is we help companies that are building data centers to ensure that they're getting what they paid for when they engage with design engineers or construction companies. So we ensure that their designs are tier compliant. We ensure that the facility was built to the design, but also performs to it and meets all the tier requirements. We help clients with understanding how to operate their data centers, because as you know, designing a data center to the highest standards only gives you the opportunity to meet your availability needs. But you have to, the operations is where that investment is realized over time. So you invest in a large facility with high quality systems and a good design. But if you don't have a good operations team, you're not going to realize the availability that facility can give you. So we help them with that as well. We're also helping clients understand even non-tier rated facilities, existing facilities. We help them understand what their risks are. So we help them to look at their operations teams, their actual facilities, and help them understand what that facility can give to them over the long haul, how it's going to help them meet their specific business needs, but also what those risks are and where they need to kind of plug some holes of those risks. So that's where we're at today.
Gotcha. Good stuff. So, Chris, as you guys look at the industry and you got a great view on where our space is going, I'd love it if you'd tell me, hey, Raymond, one is no one's talking about this, but we ought to be. So with that, no one's talking about it, but we ought to be. What would fit in that category for you? No one in the industry is really talking about it, but I think this is going to be something we're thinking about in the future. I'm hitting you with that one by a little bit of surprise. And then everyone's talking about this, and I don't think it's as big a deal as it is as everyone's making it out to be. Both of those two categories.
One that few people are talking about that I think they need to be talking about, it kind of goes hand in hand with, the example I would have for both of your questions. They go together. So sustainability is a big industry topic today, and everybody's looking at sustainability. And countries are looking at how to get their grids more sustainable and how to advance their grids to have more renewables. We have, and data centers are doing the same sort of thing. In that, though, we're going to be in periods where there's going to be a little bit of instability in the grids. Texas saw that this year, right? I mean, they had some problems because we had what I call the Great Freeze. So cold temperatures that no one had seen in a long time, no one expected, even up here in Oklahoma where we had 19 degrees below zero, something we hadn't seen in a long time. And we see some colder temperatures than Texas does. But it created some moments of instability in the grid because, of course, there was less power available than there was load, right? And so one of the things that, everybody's talking about sustainability, and it's a big deal. And along with sustainability, you have engine generators. And everybody looks at the engine generators from the data center world as being big polluters. And the reason they look at them as being big polluters is when they operate, sure enough, they do pollute into the air. Right. But of course, there's processes to help reduce that, such as urea treatments, catalytic converters, those sorts of things. But most people don't realize that they only pollute when they run. And they don't run that often, but they're a good insurance policy for the business, right? Because when you need them, you need them. And if you didn't have them when you needed them, you'd be wishing you did. Well, one of the things what we're seeing and what I'm thinking, and only a few people are talking about this, is that we can't move our energy grids in the U.S. or any other country, any modern country, from where we stand today straight to a green, carbon neutral, resilient grid. There's going to be problems along the way, right? I mean, we understand how to operate with coal-fired plants and with nuclear plants and with natural gas-fired plants, because all that's base load generation. Renewable is not base load generation. So over time, we're going to try some things and we're going to have some successes and we're going to have some failures. And so one of the things that I think is that the industry needs to be looking at and sort of touting, if you will, and we need to be ready to do is when there's instability in the grids because there's not enough capacity for the load. Data centers they consume a huge amount of power. We all know that in a very small footprint, but we have our own systems for generating power on site when we need to for emergency situations. And I think that, data centers can serve a big role in the sustainability world, helping us figure out how to get what is that right balance between baseload generation and renewable sources on the grid, and how's that look? What do the control systems need? How do they need to change? How do those algorithms need to change? Because when you stub your toe, and there's a time when, for some reason, the power companies didn't anticipate a heat wave like you'd have in Texas, or a sudden cold snap, which is going to put a lot more load on the grid. Data centers can help out because they can pull huge amounts of load off of the grid and help to stabilize the grid. But they can only do that with engine generators and other reliable sources of power that we serve today. And so I think that that's a big piece that we're going to be spending a lot of time. The data center industry can help that out. So I think the thing that people are talking about is sustainability. What they're not talking about is how we can help not just our industry, but the larger society as a whole get to where we want to be.
Yeah, I want to make sure I understand what you're saying. What I think I hear you saying is, hey, Raymond, everyone talks about sustainability, and yes, that's a thing. But and yes, they look at the data center industry and say, wow, you guys eat up a lot of juice, right? So let's think about the juice for a state as one set of capacity. What I think I hear you saying is, hey, when a system is strained, when a state of Texas's capacity is strained, all the data centers conceivably could go offline and run on their generators and produce their electricity on site, thus providing relief to the grid. And when's the right time to do that? And how do you do it? And how do you compensate them for that? And how do you think about that? Is that what I hear you saying?
That's exactly what I'm saying. The stint that I had with the petroleum industry at Citgo Petroleum, Citgo is a company that has roots, years and years in the past. And they have a lot of power contracts that go back to 50s and the 40s and things of that nature. And they had set-asides with the power companies because they run huge pumps, right? 2,000 horsepower pump motors, all powered by electrical power. And they could get at their facilities called by the power company and say, hey, look, we need this much load pulled off the grid for this amount of time. Now, if you're just pushing power to the to pipelines, you're just pushing that product on the pump lines. Well, if you have to wait an hour, that's okay, right? So they'd pull the power off the grid. That would free up capacity, and then the power companies would then sell that on the spot market, which the difference between what Citgo was paying per kWh at their contract and what they would get on the spot market was a lot. There's a big delta there.
Sure.
And
because it was a high demand window. Yeah.
Yeah. And Citgo would get a small cut of that action. And so it did a couple of things. They were good corporate citizens, so they could help free up power when power was really required. And they got a little bit of reward from it from the power company because they got a little cut of the profits off of that. Right. And so what I'm saying is that, and it's already happening in some places where data centers can sign up with power companies to be part of that set aside. And if a power company sees, hey, look, my grid's becoming unstable because I don't have enough capacity, it's going to take me a little while to spin up some more turbines or something, then they can call up the companies that are on that list, and they'll pull that load off of the grid. Well, that helps to stabilize the grid because you've now starting to match capacity to load and give them time to respond with some of their base load generation. And so I think that's an approach that we need to be looking at as an industry, partnering with the utility companies, because as the utility companies go to modernize the grid and transition how we're producing power, we're going to have times where we're going to stub our toes, right? I mean, living in Texas, I remember those times where you'd wake up in the morning and it would be 50 degrees in the morning, but by the afternoon it was in the 80s or 90s, and everybody comes home and throws on their air conditioners because they didn't have them on previously. Right. And you get times of brownouts. Yeah. And that was with years and years of experience of baseload generation with coal fire and natural gas fired power plants. Now let's add some wind into it. Let's add some solar into it. And, you've got a whole different system now. Yeah. Yeah. And I think that's and we're not going to get lost in electrical engineering, but I do think that's one of the things that people struggle to understand is that storing electricity is hard. You generate it when you need it largely. I'm oversimplifying. And you can tell a coal-fired power plant or a nuclear-fired power plant or hydro plant, you can tell it to run or not to run. You can't tell the sun to shine, and you can't tell the wind to blow. It blows when it wants, and it shines when it wants. So you don't have the on-off switch ability of generation that you have from traditional power facilities. So it's, like you said, when the demand comes, if you don't have the supply, we're breaking the system. Well, and the other part of the problem is because the wind cannot blow, or you can get heavy overcast, all of a sudden.
Mm-hmm.
So you can lose some of your capacity from your renewable systems, right? And it takes time to bring those large turbines online, get them spun up, producing power. If we think in our data centers, you can have a quick start engine generator online producing power in 10 seconds.
Right.
Not so much at the power company level.
Right. The bigger it gets, the longer it takes, no question. Very cool stuff. Well, Chris, this has been awesome. I really appreciate you spending a little time with us and hanging out and talking. We are not only are we good friends with the Uptime Institute as an institution, but also with lots of folks there, and we're grateful to be partners with you guys and grateful to have you come tell us a little bit about your story, as well as help people understand what Uptime does in the space and how you guys are really, I think, shepherding the industry and advising people on how to. I like the way you said it. Hey, you paid for this design, you paid for this deployment. Is it actually there, and does it actually work? Because at the end of the day, all people want to know is, hey, are my servers on and can I talk to them? And you guys help folks do that. And we appreciate it and appreciate the standard you guys set in our industry.
It's been my pleasure.
Chris, thank you so much.